This afternoon, John will speak to us about New Horizons. John, over to you.
Thank you. I consider myself very lucky, having been born shortly before the dawn of the space age, and that being interested in astronomy, I have been able to see through my life exploration of the solar system of some ways that would not have been dreamed of even 20 years before I was born. I was always concerned during my life that I might not see a probe to Pluto, because there were a number of schemes that were come up with, particularly by the US Space Agency NASA, Pluto Express, Pluto Fast Flyby, and although they were started, in every case the projects were abandoned. And I really did fear that I might never get a chance to see this amazing little world at the edge of our solar system. No longer unique, of course. It's a dwarf planet. We know now there are many, many objects out there beyond Neptune, but Pluto was something I really wanted to see. I was reminded of those thoughts earlier on today, when people were talking about space probes that may be launched in 2022, that may get to where they're doing in 2030, and I thought to myself, I don't want to wait that long. I want to know now whether there's an ocean on Europa. I don't want to wait till I'm in my late 70s. So I'm still waiting and wanting things to happen. But at least in the endeavour where Pluto is concerned, I was very fortunate, as we all were in this room, because due to a remarkable piece of work, particularly by project scientist Alan Stern at Southwest Research Institute, whose drive and energy and vision made the Pluto mission a reality, with his huge team that he gathered round him. And it's a testament to him and his team that the results from Pluto have been so spectacular. It's only 9.5 months ago, on the 14th of July last year, that New Horizons flew past Pluto, and we got those amazing results. They're still being analysed. The many gigabytes of data, taken months to come back from the spacecraft, as it even now speeds out of the solar system, hopefully to rendezvous with yet another Kuiper Belt object sometime maybe in 2019. Now, of course, Pluto is an unusual object in the fact that it's very small, and it has an unusual orbit, a very elliptical orbit, tilted at over 17 degrees to the plane of the ecliptic. And you can see here that when at perihelion, it's just inside the orbit of Neptune, whereas at aphelion, it's well out beyond Neptune's orbit. Now, Pluto passed perihelion in 1989, and so its distance from the Sun was increasing year on year. And there was this desire to get a probe to Pluto before it was too far from the Sun, because they wanted there to be some activity, some interesting things going on. And they feared that if it had gone too far out, that it might have been frozen solid. I don't think anyone in their wildest dreams would have anticipated the enormous range of phenomena and surface features that we would find. This is the New Horizons spacecraft, and it was designed and put together in record time. It was launched in January 2006, and it had to be launched then within a very short launch window to take advantage of an alignment with Jupiter. Would mean you could send New Horizons from the Earth past Jupiter 13 months later, get an enormous gravity assist from Jupiter, and then speed it on to Pluto in just 9.5 years. Now that sounds a long time, but it's a lot better than it would have been if the Jupiter gravity assist had not been possible. So launching on time was crucial. So here we see the red trajectory of New Horizons. It was the fastest spacecraft to be launched from the Earth, and 13 months only after launch, it passed the Jupiter system. Here you see it heading out, crossing the orbit of Mars. There's Jupiter coming in at the top there. It speeds past Jupiter, gets this enormous gravity assist from Jupiter, which not only speeds it up but also slightly tweaks its orbit to take it into the correct trajectory to bring it to Pluto, which of course is not in the plane of the other planets. And here you see it going out beyond Saturn's orbit, beyond the orbit of Uranus, and coming out right into the outer solar system. You can see there it's above the ecliptic plane there, beyond Neptune's orbit, and finally arriving at Pluto, and in July last year, and passing Pluto and its system of moons. Although, of course, we've learned a lot more about Pluto's moons during the time that the project was being developed, mainly due to the Hubble Space Telescope. Now here you can see one of the approach videos. This projector, by the way, projects rather too much in the green and yellow, so the colours are not coming out as well as one might hope. But you can see there that Charon, the largest moon, is going round Pluto in 6.4 days, about 6 days, 9.5 hours. And you can see also that the two are locked together in a quite unique way, in that Charon takes 6.4 days to go round Pluto, Pluto is spinning in 6.4 days, and Charon is spinning in 6.4 days. So on one side of Pluto, you see Charon hanging in the sky above, never moving. On the other side of Pluto, you don't see Charon at all. It is always there, if you like, hovering over the same part of Pluto. Now this is the New Horizons spacecraft. You can see there the main instruments. We have the particles experiment at the top there, Pepsi, the solar wind experiment, SWAP, Lorry, which was a high resolution black and white imager, the student dust counter underneath, and then Alice and Ralph would do the colour and spectral information, and Rex, the radio experiment. Just below the word Rex there, you can see the radioisotope thermoelectric generator, which provided the electrical power to keep the spacecraft operating at these enormous distances from the Sun. So there we can see two images of Pluto taken by New Horizons as it approached, with Charon in both. Now, because New Horizons was going to hurtle past Pluto at 13.8 kilometres per second, it would only be able to get high resolution images of 1/2 of Pluto. So in other words, as it approached, we would see views of the other side of Pluto. We would only get really high resolution images of both 1/2 of both Charon and Pluto. Now here you can see on the left there the so-called encounter hemisphere. This was the side that would be imaged at high resolution during the flyby, and you'll notice this very prominent heart-shaped feature there, which is quite bright. This is the opposite hemisphere, which does not have any really obvious bright features like on the encounter hemisphere, but it does have this line of very dark spots there, which you can see quite clearly. You'll notice that Charon has this very dark spot at the pole, and is otherwise rather greyish, in contrast to the brownish, almost pinkish colours of large parts of Pluto's surface. Now here we have a series of the approach images going from the 22nd of June, top left, through to the 1st of July, bottom right. And you can see that as the range from the spacecraft to Pluto slowly decreased there, from just under 27 million kilometres to just under 16 million kilometres, the amount of detail is becoming ever more apparent. Now, interestingly, by the time we got to the beginning of July, the quality of the images was very similar to that obtained by the Hubble Space Telescope in previous years. This was mentioned this morning, and you can see there a series of images taken by the Hubble Space Telescope, Advanced Camera for Surveys, High Resolution Camera, and you can see there that the surface features that we saw in the approach images from New Horizon are certainly picked up by Hubble. You'll see there is the white heart-shaped feature here, and the line of dark spots also was picked up by Hubble. So it is remarkable what the Hubble Space Telescope is able to do from orbit round the Earth, comparable with the spacecraft at a distance of about 16 million kilometres. From that moment on, from the 1st of July onwards, the images we were getting from New Horizon were always better and better than anything Hubble had ever done. Hubble also, though, let's not forget, had discovered 4 new moons of Pluto. The largest moon, Charon, to which I've already alluded, that was discovered by Jim Christie in 1977 from the US Naval Observatory. The 4 other moons of Pluto, and you can see them here, Nix and Hydra, and Styx and Kerberos, they were discovered by Hubble Space Telescope in more recent times. And the reason that Hubble was tasked with surveying the area around Pluto is because when you have a spacecraft hurtling through the Pluto system at 13.8 kilometers a second, you do not want to hit a moon that you previously knew nothing about. So it's a good idea to know what there is in the vicinity, and the 5 moons of Pluto were mapped accurately by Hubble, and you also heard this morning that some photometric observations of Nix and Hydra by Hubble enabled us to work out that not only were they highly irregular in shape, but they were tumbling in a quite chaotic way. Now, New Horizons, of course, is approaching at ever-increasing speeds there, and heading on for the encounter on the 14th of July. So that last 2 weeks before Encounter Day, we were getting better and better information all the time. But we must remember, of course, that there's a long time lag of over 5 hours from when the spacecraft sends us any information to when we receive it at the Deep Space Network on Earth, and of course a similar time for us to send information back to the craft. So this is an early distant view in that 2-week period leading up to the close encounter of the encounter hemisphere. So this was the half of Pluto that we were going to see in stunning detail at the flyby on the 14th of July. You can see there this very prominent heart-shaped region that I've alluded to earlier, and the darker areas around Pluto's equator. One of the things it's important to realise is that Pluto's axial tilt is extreme, 103 degrees to its orbital plane, which means that you're looking here at the northern hemisphere of Pluto. The equator of Pluto is round there. Virtually none of the southern hemisphere, and certainly not the south polar region, they are not visible at all. You've got the North Pole here, and the North Polar region tilted very strongly towards the spacecraft and, of course, to the Sun. So that was the encounter hemisphere, our views of it, 1 rotation period before the actual close encounter. Then, of course, that hemisphere turned away, and we then got images of the hemisphere that we would not see in great detail, and you can see here that line of dark spots around the equator that I mentioned earlier, some features that do look as though they might be craters or something similar to craters. And if you compare this image with the next one, you'll see there's a certain amount of rotation there between them. I'll just flick back again. So in between these 2 images there's a certain amount of rotation, and now we're just beginning to see the bit of the right-hand piece of that heart-shaped feature coming round the corner, and so we're getting closer and closer to encounter. This part of the surface will be turning away from us, and this part will be turning towards us, and will be the part surveyed closely by New Horizons on the 14th of July. So here we have a series of images showing a complete rotation of Pluto. Here we have the encounter hemisphere, and here we have the opposite hemisphere with those large circular features and dark markings around the equator. But there's also, as you can see, this very large dark feature around the equator, extending from just below the heart-shaped feature and round the equator there. Now here we have Pluto and Charon side by side. Now Pluto should be more brownish with a slight pink tint. It shouldn't be yellow as this projector shows it, but you'll notice that even here it is quite clear there's a very different colour between Pluto on the right and Charon on the left. Whereas Pluto has the large white areas, particularly the heart-shaped region, and also areas of brown, almost pinkish. Charon is largely greyish with a slightly darker north polar area. Now, both of them are made predominantly of water ice. We heard earlier that in these outer solar system frozen objects, water ice takes the place of rock from the substance that makes the main body of the object. And then you might have surface coatings of other ices and snows that give you the colour. Now, in the case of Charon, although they are both, as I say, made of water ice, frozen at around minus 234 degrees C, in the case of Charon, there must be a very different surface covering, or none at all, compared with what is going on Pluto. So here's the trajectory through the Pluto system. You can see, as I said already, Pluto's tilt, 103 degrees, means that the New Horizons trajectory was coming up almost at right angles to the orbital plane of Pluto's 5 moons. Now, remember, the sun is shining from the right. So we have here the shadow of Pluto and the shadow of Charon. And you can see there that because the sun is shining from the right, all of the bright illuminated hemispheres have to be done on the inward part of the trajectory. So as New Horizons comes in, it's taking images, Pluto, Charon and the other moons, where they are lit by the sun, and then as it goes behind, it's then looking back and is going to be seeing the objects backlit by the sun. And you'll see there are 2 points, one there and one there, where New Horizons passes actually through the shadows of Pluto and Charon. And we'll talk about why that was important a bit later. You can see there the encounter distance from Pluto, 12,500 kilometres and just under 7,800 miles at a speed of 13.8 kilometres per second. So on the way in, we had a look at the moons. I'm going to look first of all at some of the smaller moons and then Charon. So here we have 2 of those smaller moons, Nix and Hydra. These are of the order of 30 to 40 kilometres in dimension. You can see there that Nix appears to have a slightly different surface coloration to Hydra, and those are certainly very irregular objects. I already mentioned that Hubble had shown us that these irregular objects are tumbling and rotating in a quite chaotic way. There is an image of Kerberos. Kerberos is very small, and it is probably of the order of 10 kilometres to 15 kilometres. And you can see, it's interesting, because it looks as though it has almost a sort of a shape a bit like Comet 67P. That we've already seen. We've had that model being passed around earlier. It always strikes me looking at this that Kerberos appears to have that sort of dumbbell or double-lobed type appearance, although we haven't got any really detailed images of Kerberos, and it is rather small, as I say. And then we have the best image released so far of Nix. So this is that irregular ellipsoidal moon, and you can see there with quite a few surface craters shown in that view. Now here we have Charon. Now Charon, Pluto's largest moon, a diameter of just about 1,170 kilometres, and you can see there it has this incredibly rugged surface. There are some craters, perhaps not as many as we might have expected, a very dark north polar region, this incredible cliff system extending all the way round here, and then these very deep canyons at the top. Now the cliffs are of the order of 4.5 kilometres high. The canyon system is the order of 6 kilometres deep. Now these, remember, are not sculpted out of rock. This is sculpted out of water ice frozen as hard as rock. Now when we look at Charon in more detail, we begin to see a wide variety of surface features, and the problems for the scientists involved is that when you're trying to talk to your colleagues and other members of the scientific community about different features on the surface, there has been nothing officially named. So they had to come up with names themselves so that they would know what the heck they were talking about in conversation with each other. And you can see they've been quite inventive. We have Mordor for the dark region at the North Pole after the Lord of the Rings. We have Vulcanplanum. We've got various other ones there. Kirk crater, you can see, for example, Uhura crater, and Kubrick Mons. So all sorts of science fiction and other features used there just as a way of identifying features. These names are all informal, but at least they help us know what we're talking about. So here again is a complete rotation of Charon. You can see there just how very, very obvious this incredible ridge going all the way, or cliff really, going all the way round Charon is in those images. So here we see a swathe across Charon, particularly even across that. Now, this side of Charon that we actually saw in detail from New Horizons is characterised by this system of pull-apart tectonic faults, ridges and scarps and valleys. As I've said, the ridges and scarps, 4.5 kilometres, that enormous canyon reaching 6.5 kilometres deep. What on earth could be going on? Well, there we have the best image of Charon released so far, and it appears to be a very interesting scenario. This moon is made entirely of water ice, frozen as hard as rock, and there appears to be very little in the way of other ices on the surface except around the North Polar region. This, remember, is Mordor Macula, where there appears to be a dusting of perhaps methane ice, maybe discoloured with some other chemicals, which I'll talk about in a moment, to give it this brownish type appearance. But this incredible series of faults all the way round it is really quite dramatic. And it appears, one of the best theories at the moment, is the idea is that long ago radioactive heating or heat released from radioactive processes deep inside Charon melted part of the internal of Charon, and basically you had an icy crust, a deep layer of slush or maybe even water, and over a period of time, as that heat subsided, that liquid layer, which had been liquid, froze. And we all know what happens when water freezes, it expands. So, as the layer underneath the crust of Charon expanded, it popped the crust open. And the best way of imagining this is just as the Incredible Hulk changes and his muscles become huge and he bursts out of all of his shirts. It always occurs to me his wife must wonder what on earth he does with his shirts. But the fact is, that's what's happened with Charon. It's burst itself out from the inside, and the crust has been pushed and cracked and popped, and that's what you're seeing here. It's a remarkable idea, but it does seem to fit what we actually observe. So, for a long time we've believed that Charon and the other moons were probably formed by a very major impact early in the system. So in other words, Pluto was smashed into by a large planetoid, icy planetoid, probably in the outer solar system, and this plastered material outwards, which made Charon and also the other moons. Now, if that was the case, the craters on all of those objects should be about the same age, because all of the cratering record of those moons would be similar, because they'd all have been formed about the same time. The question is, did this giant impact happen in the early history of the solar system, or did it happen more recently? And we should be able to tell by investigating the cratering record of these moons. Now, Kelsey Singer of the Southwest Research Institute showed some results at the Lunar and Planetary Science Conference just 4.5 weeks ago, and these are her results that I'm showing now. So here we've got 585 craters on Charon that are mapped. You can see this is the area that's been mapped, this is the area not, and you can see the distribution of those craters. And the idea is you look at the number of craters you've got of different sizes. So you have to not only measure them all, but count them all as well. And then the same thing's been done with Nix and with Hydra, although of course the numbers of craters are much less. But you then get the size distribution of these, and you plot them on a graph here, and you can see that the Charon data, which is the most extensive, which is green, beautifully fits on this line, but so does the data from Nix, and which is the orangey points, and Hydra, and you can fit that line to it, and that tells us that all the crater ages date from about 4,000 million years ago. In other words, all of these objects do have the same or similar cratering record, and it dates back to ancient times. So this giant impact theory for our idea of how the Charon and the other moons were formed appears to have been early in the history of the solar system and not more recent. So that's a very nice piece of work by Kelsey Singer there on the cratering ages of these objects. Now, New Horizons, of course, passes Pluto on the 14th of July, and here we have a lovely false colour image, but showing us very many different sorts of terrain. In the North Polar region, we have this very slightly brownish area. We have this huge white heart-shaped feature that we even saw in the Hubble images way back, but you'll notice it's very, very clear on the left side, but rather more broken on the right side there. And then you have this extensive brownish area extending round the equator, and there are other areas with a definite brownish tint. So a big diversity of surface terrain. Again, we have to know what we're talking about. So again, we've come up with all sorts of different ideas for names. The whole of the heart-shaped region was named Tombaugh Regio, after Clyde Tombaugh, the discoverer, back in 1930. The left-hand side of the heart shape is called Sputnik Planum. And you'll notice that many of the features here are named after spacecraft: Hayabusa, Pioneer, Voyager, and others. So lots of names again, not official, all informal, but again essential so we know what features we're talking about. Now here we've got a close-up of Sputnik Planum, and you can see there that there are various other areas around the edge, Sputnik Planum being the left-hand side of the white heart-shaped region, and Sputnik Planum is the area where the white is very obvious and there's not patchy, but you'll notice that there are interesting features around the edge. And in fact, Sputnik Planum has been one of the most widely studied regions on Pluto. You'll notice also here Columbia and Challenger, the two lost space shuttles, are also remembered here, along with various other features. Now here's a close-up of that area. We got this is Tombaugh Regio, this whole area here. We have Sputnik Planum here, and again we have this very extensive brownish region extending round. This is one of the early images of Sputnik Planum, and you can see straight away it is a very white, flattish area, but it does have this very strange structure where it seems to be broken into segments here with boundaries between, and we'll look more at that in more detail. But then there are these very interesting lumps here sticking out, or maybe on the surface of this sheet of material. Here we're now going to look at the top left corner of Sputnik Planum here towards the northern edge, because there's some interesting structures here. And there we can see Sputnik Planum, the rather flattish area, with these strange polygonal cells. But then there's what looks like flows. Now, it turns out when we do the measurements that Sputnik Planum is made of nitrogen ice. And what it appears to be happened, or has happened in the past, is that the nitrogen has flowed into the valleys, and it might have flowed into the valleys this way, or some people think there's a possibility it might have at some time become volatile, then deposited on the mountains, and then flowed back in channels down to the lower level. In either scenario, a very interesting case. You don't imagine on a world where the temperature's minus 234 degrees C, unless you think about it carefully, you don't really think that you might have things like flows going on. But you certainly can, as we shall see. So now we're looking at the other end of Sputnik Planum, at the southern edge, and here we have two extensive areas of what I'm going to call mountains. Norgay Montes, they are the highest of these mountain peaks, and they are rivaling the heights of the Alps in Switzerland. The Hillary Montes are not so high, they are more like the height of the Appalachians in the US. Obviously, the names after the first conquerors of Everest. And we have Sputnik Planum up there extending with that polygonal structure. We have various things that look like craters, maybe filled with ice, and all sorts of other interesting features as well. So, the diversity of Pluto's landscape stems from long periods of interaction between the highly volatile and mobile ices of three things: methane, nitrogen, and carbon monoxide, overlaying a much sturdier and inert water ice. The water ice is solid, hard, but on the top of it there are these ices of the other three substances which are volatile and mobile. And the variations in the distribution of those three volatile ices points to some cycles of evaporation and condensation over very long periods of time. Here on Earth, of course, we've only really got one material that condenses and evaporates in that way, and that is water. But on Pluto, we have three such materials: methane, nitrogen, carbon monoxide. And so here we are again looking at the view of Pluto we've seen before, and we're particularly interested perhaps in this brownish material. And that brownish material, which colours parts of Pluto's surface and maybe even part of the North Pole of Charon, is probably related to substances called tholins. If you take a mixture of methane and nitrogen and you subject it to ultraviolet light from the sun, you get made this brownish, fine, powdery material. And it may well be that that is exactly what is colouring those areas of Pluto. So we have another substance, a compound produced by the action of solar ultraviolet, that is producing that brownish, pinkish coloration to parts of Pluto's surface. So here we have these areas. This is over on the centre of the heart, if you like, of Sputnik Planum, and you've got the polygonal cells, the Challenger ridge there with Columbia one above it, and you can see here there's features that look like flows, that might be glaciers, but you then have these sort of areas of what you might call water ice hills. Let's have a look at them a bit more closely. There they are. So this is zooming in on that area, and you've got these water ice hills there. Now it's thought that they may be fragments of the more rugged uplands here that have broken away and been carried down by nitrogen glaciers onto the plain of Sputnik Planum, which is overall nitrogen ice. The hills cluster in groups about 20 kilometres across, and because water ice is less dense than the nitrogen-dominated ice, the water ice will basically stay on the top. So the nitrogen-dominated ice will be the underlayer, and the water ice will stay on the top. So these are probably lumps of water ice. We're going to see them in more detail in just a moment. So this is really high resolution now at the northern end of Sputnik Planum. It's showing you these strange polygonal cells and the very sharp delineation between where the polygonal cells stop and the uplands, and it's almost like a shoreline. And although the nitrogen is of course solid now, it may well not have been in the past. We're moving down now, and we've now got these strange features, these raised centres there, but these ridged margins to the polygonal cells. So the cells are between 15 and 40 kilometres wide, and it's thought that the pattern of cells is due to the slow thermal convection of nitrogen-dominated ices. So they basically rise in the middle and fall at the edges. So these areas, these boundaries, those margins, those ridged margins, are the areas where these convection cells are separated from their neighbouring ones. Now, here we've got two of these large, dark lumps sitting on the top of the nitrogen ice, and they appear to be moved towards the boundary. Now, it's thought that those are blocks of water ice, dirty ice perhaps, floating on the denser solid nitrogen, and they're dragged to the edge of the convection cell by movement in the nitrogen ice. So the nitrogen ice is very slowly convecting up, moves to the edge of the cell, and these water blocks, and some of these water blocks would be maybe 30, 40, 50 metres in size, are carried to the edge where it then descends at the margin of the cell. When I first looked at this picture, it looked to me like a snail. And I thought to myself, there's a snail travelling across the surface of Pluto, till I realised how big it was. It's a very large snail. But as I'm not a member of the European Space Agency, I don't spread rumours about snails crawling across the surface of Pluto. So here we have a region, the Alidris Montes, an example of chaotic polygon-shaped terrain. Now this, again, is an area where we have large, broken-up areas of water ice merging with a boundary of the polygonal-celled region of Sputnik Planum. And it's very interesting to look at the processes that must have been going on the edge here between this largely water ice-dominated region, but blocky and lumpy, and the much smoother nitrogen ice-dominated region. Now, when we look in the craters here, we find also some interesting features, but I'll come to that in a moment. This is the North Polar region of Pluto, Lowell Regio, and it appears to have areas of methane ice on top of the water ice. But notice that the surface looks quite eroded. It does look a rather ancient part of the surface, and it's thought that this is much, much older than the region near the equator. There are canyons running across it, the widest 75 kilometres wide, the narrowest 10 kilometres wide, and they run for great distances, several hundred kilometres in some cases, across the North Polar region. Mapping the water ice on Pluto was tricky because when they first started, they found that there was a problem with contamination with methane ice, so they had to refine the technique over quite a few months. And on the right there is the latest result for the mapping of exposed water ice on Pluto's surface. So the exposed water ice is blue. Now we know here, Sputnik Planum, that is largely nitrogen ice. We know that this North Polar region obviously has a covering of possibly methane ice. There may well be methane and even carbon monoxide ice in pockets around as well. So you can see that in many places the underlying water ice is not exposed to view, it is covered up by other ices. Here we have an area known as Vega Terra, and we can see here two areas. We've got a black and white image at the top and the colour spectral image below. That shows you where it is on the surface. Let's have a look at that in more detail. What we've got is that the crater floors and the terrain between the craters show signs of water ice, which is mapped in blue, whereas the bright methane ice in purple settles on the crater rims. We've also found that there are areas where the tholins, that's that reddish browny particle material, settles into the floors of craters or in flat low-lying areas. Here you can see one of two possible cryovolcanoes. This is an area where in the past there might have been eruptions of nitrogen ice from beneath the surface, and you can see here it's quite a large structure. It's 150 kilometres across and about 4 kilometres high, and you can see there's the central part of it. So these cryovolcanoes, of course, are great interest. We have them on a number of other places in the solar system, and be interesting to see whether we can work out when this was last active. Here's a close-up of Right Mons. We're looking now right down into the heart of the cryovolcano. Really remarkable image when you consider this is only 150 kilometres across there, and lots of interesting features there, structures, ridges, raised areas and grooves. So lots of interesting features to analyse and look at the history of the region. So remember that as New Horizons came through the Pluto system, it would pass first through the shadow of Pluto and then through the shadow of Charon, and as it did so, this is what would happen. So we've got New Horizons there speeding away from Pluto, and at this point you can see if Pluto has an atmosphere, there'll be a ring all the way round the shaded disk of it. And there it is. There is the atmosphere of Pluto obtained by New Horizons, and it is largely an atmosphere of nitrogen, but in that atmosphere are microscopic particles of tholins. That material that's a mixture of nitrogen and methane acted on by ultraviolet, and when that happens you get these particles suspended in the atmosphere. They produce Rayleigh scattering, just like the atoms and molecules in our own atmosphere, which makes the sky here blue, which means that that ring of light on Pluto would actually be blue as well, from the same process, scattering. So the particles, the very fine particles of tholins in the nitrogen atmosphere produce the scattering. Now what was a surprise is that the atmosphere of Pluto is so highly structured. There are dozens of different haze layers rising above the surface, and here you can see, and this is the highest resolution image released yet, of the incredible structure in Pluto's thin atmosphere. Now this is very tenuous nitrogen with the tholins suspended in it, but what's interesting is we thought that the nitrogen atmosphere would quickly be lost due to the solar wind. It turns out that the loss of the atmosphere of Pluto is no greater than the rate at which Earth is losing its atmosphere due to solar wind activity. So in other words, far from being an atmosphere that would be lost quickly, the atmosphere of Pluto appears to be very, very stable in the long term. Now, the seasons of Pluto and the long-term climate change are very, very complex. The orbit, as we know, is elliptical, but what is more important is the extreme tilt of Pluto's axis of rotation relative to its orbital plane. You can see here that in 1989-90 it was at perihelion. The equator was then facing the sun. We're now in the northern spring. The northern hemisphere is tipped towards the sun. The southern pole is turned away. And you can see that in the 248 years that Pluto takes to go round the sun, we have these very long seasonal changes. But that's not all. Modelling by Richard Binzel at Massachusetts Institute of Technology has shown that over long periods of time, 800,000 years into the past, 600,000 years into the future, that there will be big changes in the way sunlight falls on the surface of Pluto. And you can see here we're currently in what we might call an intermediate climate epoch. And Richard Binzel has concluded that Pluto has clear climate forcing cycles, just like the Milankovitch cycles here on Earth, that these cycles last millions of years, that they shape the long-term transport of volatiles from the equator and poles and back, and that we're currently in an intermediate climate state between two extremes. To investigate those extremes, Alan Stern of Southwest Research Institute looked at those extreme climate points. Here we are. So from 800,000 years in the past to 600,000 years in the future. So here we're going from the present epoch, this intermediate climate state, all the way back to a period 800,000 years ago when we had extreme northern summers, to a period some 2.3 million years ago when we had extreme southern summers. And this produces very long-term changes in the way Pluto is heated over many, many orbits, and will be responsible for long-term changes in the deposition and condensation of volatiles. A number of features on the surface may provide evidence that there was an even higher pressure atmosphere in the past. You can see here frozen ponds, networks and branching valleys on the surface. And Alan Stern concluded that the atmospheric pressure may vary by 3 to 4 time orders of magnitude. That's a staggering amount, between 1,000 and 10,000 times over those long cycles of millions of years. The current atmosphere is a relatively low pressure. Maximum pressures may even exceed the pressure on Mars by 4 to 40 times. In extreme cases, the pressure and temperature may exceed the triple point of nitrogen, allowing it to be stable as a liquid on Pluto's surface. So clearly, the study of the climate and long-term changes on Pluto is only just beginning. New Horizons goes out now to carry on its exploration. Hopefully the plan to get it to go on to another Kuiper Belt object in 2019 will be approved. And people often say to me, is there any life on Pluto? Well, yes, Pluto the dog obviously lives there. Thank you very much.